Welcome everybody to be here in tropical Melbourne. You can see all the New South Wales and Queenslanders here with their 3 jackets on, so it's good to see you all coming from interstate. I'm here as introduced to not talk about Fair Farms, so that's already been covered pretty well. I'll go back the other way. Okay, that makes more sense. All right. Obviously, this was a fairly hot topic last year, and it is a little bit of a technical topic, so I don't want to give you death by PowerPoint because it can be a little bit involved. So, essentially, I just want to spend the first sort of 5 or 10 minutes whizzing through some slides, but mainly I want to defer to your hands because there's people from all sectors of the fresh produce, whether it be growers through supply chain and obviously retail in this area, and probably want to really open up to questions and to see what challenges you guys or questions you guys have as an audience. So there's some data here which we can make available to you about what can and can't be inspected in fresh produce, and for the most part there's 2 technologies. There's X-ray and metal detection. Primarily in fresh produce you see metal detection because it ticks the main compliance box. X-ray really is only used if you've got some metallic material in your packaging, like foil bags or metal clips and those sorts of things, where obviously you can't use a metal detector, or if you've got challenges with other contaminants like glass or other high density materials that you would want to pick up in an X-ray machine. So X-ray tends to be, I'll just put up this as a bit of a general idea, but X-ray, as you'll see from the top line there, is a much more significant investment. And seeing as it's a compliance cost, which you don't really want to have to spend, but you sometimes find yourself in that conundrum. Metal detection is far more common than X-ray. So this just gives you a little bit of an idea. Obviously, there's pros and cons of both, but X-ray is definitely probably 2.5 to 3 times more expensive than a traditional metal detector. And then the ongoing cost of ownership is also significantly higher because you have the world's most expensive light bulb in this sort of machine, which has to be replaced just like any light bulb when it gets used to its finite life. There's obviously some things that both machines can detect, but it's really driven by food safety, and these standards are obviously applying to all food forms, not just fresh produce. We're all covered, all manufacturers of food and beverage, anything that's consumed is dictated by food standards, and FSANZ obviously as a governing body really drive this pretty hard. But in the retail space, obviously BRC, HARPS and HACCP and all those other procedures that we're all familiar with really sort of drive the compliance at the farm or pack house level, and it's really the big 4 or the main supermarkets that dictate, especially if you're packing with their name on the produce, as to what you should and shouldn't have. But fresh produce shouldn't really have to buy, and doesn't technically have to buy or have a metal or X-ray inspection system, because let's face it, the risk of contamination when you're taking something fresh off a tree or a bush and putting it into a punnet, it's non-existent. So most site audits will say you can get an exemption from this sort of technology, and hopefully that long continues. But we've seen the trend in recent years. Obviously the larger, the Costas, the Perfections of the world, the larger players obviously see it more as an insurance thing, and obviously last year's terrible situation was really tampering. It's not contamination, it was tampering, and it's really a terrible situation. And then of course what happens with contamination, most contamination, if you're running arnots and you're making biscuits and bread and those sorts of things, contamination comes through processing. So something falls in a mixer, or the blades on a machine broke, that's a real risk of contamination. So you go to Arnott's on their Tim Tam line, they'll have metal detectors and X-ray machines everywhere because there is a genuine risk in the process. Obviously handling and storage is another risk where products can be contaminated, and that could be compromised packaging, other insects, animal contamination or those sorts of things, or damage in transit. And then there's obviously the one that was put up in lights last year, which is clearly sabotage, and it's a police matter. That, of course, in this sort of news world, it's social media that really then comes into play, and it's an animal that can work for and against the industry, because to start with it's the copycat thing that goes off the scale, and it's like an uncontrollable monster. Then of course social media can be used to bring that back into control and maybe promote people to actually help the farmers and buy more products. So that sort of thing, it's in this sort of fast-moving digital world, everything becomes news, like the previous presentation. The headlines, they like to grab the headlines and make a big story out of it. Now, Some farms last year, if we drill down on the strawberry tampering crisis last year, some farms already had metal detection in place, and it was pretty much business as usual for them. And there's Joe Schwara from Panada Farms that was on the news last year. That was one such example. Obviously, the Fazan's guys orchestrated a think tank and study into how we could learn from that situation, and that's readily available, that paper that was done by all aspects, whether it be legal, industry. And we consulted a little bit about the technical aspect of metal detection, because it can be, for people that are getting on with growing fruit and vegetables, they don't really want to learn about the boring physics of a metal detector, because you normally don't have to. But the basics, to give you an idea of what a metal detector does, it's an electromagnetic coil, and objects pass through it. They'll create a disturbance, and the weakest part of any metal detector, whether it's one that you walk through at the airport, as you can see in the picture there, or a typical food metal detector, is the middle. So whenever you challenge a metal detector, you must check it in the centre, or which is the weakest point of any metal detector. What you can detect in a metal detector is material that's electrically conductive, and this is the bit where I please try and stay awake after lunch, because this bit's pretty boring, and magnetically charged materials. So iron is a ferrous metal, is magnetically charged. It's quite easy to detect that sort of product. But when you look at potatoes, they've got a naturally high, and a lot of ground vegetables, they've got a naturally high iron content, and actually iron is more difficult to detect in spuds than, say, stainless steel or aluminium. So there's a few little nuances here, and that's why I say, long after this presentation's done, there's 3 or 4 good suppliers here, ourselves included, that are experts in this field, and please make your time to go and visit them. Heat and Control are here, Matthews are here, ourselves, so there's plenty of technical resources here to talk about this in more detail if you think it's relevant. And you can see the machines here as well. You cannot detect organic or non-conductive materials in a metal detector. Okay, it has to be conductive. And any metal detection system, and this is where it gets really different from farm to farm, there's no actual standard that says, you run a farm, you must find 2mm stainless steel. You cannot apply one rule to everybody, because what you can find varies depending on the pack size and a whole lot of other variables with products. So things in the environment, like electrical noise and vibration, those sorts of stuff. Temperature changes in a packing shed during the day. If it's not controlled, you'll get different effects on a metal detector. So there's a lot of variables. And we have on a metal detector a thing called a metal-free zone. So within normally 1.5 times the size of the metal detector, you can't have any vibrating metal or generally people moving with jewellery, which you wouldn't have in most food areas anyway. So all of those variables you've got to take into account. Then the more variables you've got that you can't control, the dumber the metal detection has to be set. So your threshold becomes higher, and therefore you challenge it with larger size test pieces. Then, of course, there's the product effect. Now, this is the bit that really gets people confused. And we had last year, when the strawberry contamination crisis happened, our phones were in meltdown, and it's like a farmer rings, I'll just put 10 boxes through a really big metal detector, that's going to make sense. But in effect, if you've lost your car keys or your phone, that's probably a good thing to use. But if you're trying to find a small 2mm stainless steel contaminant, forget it. Because the product effect of strawberries, in this case, it's pretty much sugar and water. Highly conductive. You can only find something in a contaminant if it creates a bigger disturbance than the actual product itself. So every line is programmed differently, and it's a bit of a nightmare, to be honest, for the industry to get their head around this. So yeah, things like temperature as well. There's lots of other variables that affect it. But the bottom line is, the more conductive the item, the worse the detection is. You've got to really dumb down your detection system. And I use a simple graphic. If you think of a 1mm stainless steel ball, for example, if you've got a dry or frozen product, let's say you've got a frozen tray of steak. Frozen meat is actually non-conductive. You could put 2 high voltage electrodes on either end. Nothing's going to happen, all right? And you could comfortably find in a dry or frozen product down to probably 1mm of stainless steel. As soon as you basically, a 3mm stainless steel ball is obviously even bigger, but as soon as you introduce exactly the same tray of meat, it's going to be, if it's thawed, it's now highly conductive, and that would actually mask the 3mm stainless ball. So exactly the same piece of meat, frozen compared to fresh, gives you a totally different detection parameter. So, and that's the same in fresh produce, or any product for that matter. Then, of course, you go into something like a barbecue chicken, which is salty and large and very conductive and often warm. That's an absolute nightmare. So we'd probably validate a metal detector with like a 5 or 6mm test piece. So you're starting to talk really large ball bearings with this sort of stuff. So in strawberries, for example, every production line is different. Same with most fresh produce lines. You can be putting through single punnets, 2 punnets side by side. You want to put through a tray. All of it can be inspected, but expect a totally different result from a detection sensitivity point of view. So if you're validating with a box of strawberries, for example, you might use a 4 or 5 millimetre test piece, but if you're doing single punnets in a cool room, probably 1.5 to 2 mil. So it really depends on your pack format and your setup. So there's a typical line. That's a cherry tomato line. We're running at about 200 packs a minute. They've got that set up. This is at Gyra, and they're easily inspecting down a sort of 1.5 mil ferrous and about 2.5 mil stainless. And you can see in a high-speed line like that, stuff just gets ejected automatically. There's actually a reject bin goes in there as well for securing the product. Then, of course, with a large box, you're looking at a much larger test piece, and you've probably seen things like this. This is a test kit that metal detection technicians would carry around with a myriad of different test pieces. If you haven't seen them, they're all various size ball bearings of different metal materials, and that's what technicians will use when they go and validate a metal detector. That's close up. Now, obviously, you don't use needles. Everyone was talking about needles last year. Depending on which way you put a needle through a metal detector, give you a totally different signal, sideways, vertically. That's why we always use ball bearings, because no matter what you do, it's always the same disturbance with a ball bearing. Then if you look at X-ray test pieces, they're a bit different, because now we're looking at not just metal, we're looking at glass and other materials, and we actually have test cards that you can't see from there, but there's like 6 different size balls in one test card, because an X-ray system is like a vision system, just looking through your product. So you can certainly use an X-ray system for basically finding any material that's got a higher density than your product you're inspecting. So you can't find anything that floats generally is a no-no with an X-ray. But the heavier it is, the denser it is, and most people are using it for metal still. As a rule of thumb, you can find smaller metal probably in an X-ray, assuming you're not trying to pile the product up too high, because then it just becomes a big black blob on the image. So you can't find organic or low-density materials or anything that's masked by a variation. So if you imagine a layer of strawberries in a punnet, if you start to put 2 or 3 layers of strawberries on top of each other, they overlap and look a little bit darker and darker and darker where the layers form. That would potentially hide some contaminants from being detected. So there's no precise science when it comes to this stuff, but it's more about risk reduction at the end of the day, and keeping the supermarkets happy, I suppose, is probably the overall driver. There's 2 typical examples. So the one on the large one there obviously is a massive X-ray system. So you can get X-ray systems for small individual punnets, and you can get X-ray systems for large trays and boxes. So and the price goes up quite a lot when you start to look at a really large format, probably in the hundreds of thousands of dollars for a really large format X-ray machine. But if you're thinking of, say, 10 production lines for individual punnets, it's cheaper to get a much bigger machine at the end of the line. So that's the sort of thought process you've got to go through about where should we inspect our product, what's the most suitable place. Because if you inspect it when there's too much, you're actually probably not going to inspect to a satisfactory level depending on your product. There's some metal detection tables you can see on the internet, but generally the top of that table, lead being the densest metal, is probably the easiest to find, and obviously at the bottom, things that are very low density and they get hidden by the product, they're quite difficult to find. Here's a good example of an X-ray image showing a single layer of strawberries compared to a multiple. The darker one is a 1 kilo box of strawberries. Basically, as you can see, they're all piled up on top of each other. You get these overlaps, and those red arrows show what can't be detected. So that's a stainless steel test card on a fairly low power basic punnet X-ray machine. So that's your sort of run-of-the-mill entry-level X-ray machine. And you can clearly see that as soon as you start piling up the product, you mask the contaminants. So it's not necessarily fit for all purposes, but on a single layer like the one on the left-hand side, you can clearly see every contaminant right down to 1.5 millimetres, I think that one was. So this is a picture of the guys from Matthews sell a German machine called Beserber, and this is a larger format for doing trays. So you can see they did some testing last year, and the similar sort of result. The power level on this sort of machine, you're starting to talk more than double the cost of a single punnet machine, but it is possible to do trays, but this wouldn't really work if you started to layer. So if you had a Coles B crate with 5 layers of single layer strawberries in there, it's just not going to really be effective at all. So look, that's the general overview into the technology. Hopefully you guys are still awake as far as that's concerned, but I really wanted to just open to the floor and see what sort of challenges you guys are facing, and take questions if there's any questions. I'm more than happy to answer them. And if there's not, even better. The next speaker can get on with it. No? Everyone happy? Excellent. Well, like I said, there's 3 or 4 companies here with this sort of technology, all very reputable, and most of it comes out of Europe or Japan is where most of this sort of technology comes from. And I encourage you, if you do have this sort of interest in your, or relevance in your sector, please get along this afternoon or tomorrow and introduce yourself, and you can get a demonstration, see exactly what is possible or not possible, and discuss your specific requirements. But without any further questions, I'll hand back and thank you very much for listening. Cheers.